This is the world to the power of the world. Lately, I've been doing math on the globe. By assigning a number to every location, we can calculate world cubed, or 3 to the world. And a bunch of you suggested that I graph world to the world. So here it is. There's a huge Antarctica surrounded by lines of repeating continents. In this video, we'll take a look. Hold on, there's a break in the map. See that jump between China and the US? And then the bottom of Africa is cut off. Is there an issue with the code? No, everything looks right. Let's run a test. This graph of world to the world should stay the same if we replace this with 2 world over 2. And then we can factor out the half power, giving us this. Let's update the code to graph this equation. So we'll multiply by 2, and then... Hey guys, the Gray Cuber here. Just wanted to clarify that this is not how I write my code. It actually looks like this. And you can play around with it. Follow the link in the description to try out your own functions. But anyway, let's get back to the video. And take this to the half power. And run. It looks similar to the graph above, except the Americas are missing. What if we use 10 and a tenth instead? Let's switch the code, and then, it has way more breaks. So why? Hey guys, this is the Gray Cuber. I'm realizing now that this is basically the same idea as another video I made last year, so I guess you could just watch that. There's a link in— Hey, easy with the links. We want people to watch this. Fun fact, the shape of my logo can be made by— Nobody cares. Let's get back to world to the world. What causes this break? Instead of looking at the whole globe, let's take a single number, half to the half. What is this? Well, if we square it, then the exponents cancel, leaving us with just a half. So this is the number that squares to a half. That could be around 0.71 or negative 0.71. Both are valid answers. But to make the graph, we have to pick one of them. 0.71 is in the ocean, so it's dark blue, but negative 0.71 is in the ocean, so it's dark blue. It's a bad example, but what about root 2 to the root 2? It could go here, or 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 it could... There are infinite options for root 2, because it's non-rational. And this really happens because we're treating the globe as the complex numbers. And complex exponents are weird. Let's try to solve this x to the x for every number. X can be any complex number a plus bi. We can simplify... What's up with this music notation? We should use variable... No, I like it. But the base should be in base clef. We can simplify by splitting the exponents, as you can see in this example. Now we have 2 chunks, each with just a single power. Let's start with the left. Unfortunately, we cannot further simplify by splitting the base, which you can see in the example on the right. This would work if we replace the t's with dots. So we'd like to find a way to write this number using a dot. You may have heard that e to the pi I equals -1. It turns out if we take e to any d flat I, then we get a number on the equator. This d flat determines the tude. By the way, if anyone joined the video recently, tude stands for longitude. I'm just using slang. And to get a number off of the equator, we can multiply by e to a real f sharp, which determines the tude. By the way, if anyone joined the video recently, tude stands for latitude. I'm just using slang. Every complex number can be written like this. And this is exactly what we're looking for, a real part and an imaginary part combined with a dot. So to take any x to the x, we write the exponent as a plus bi, and then we write the base using this tude format. Then we can split the exponent and split the base to get 4 easier chunks. After a little rearrangement, we end up with this. The left exponent is real, so it gives us the final tude, and the right is imaginary, so it gives us the final tude. Let's use this formula to find half to the half. If we plug in its values and simplify, this will give us 0.71. But notice, the tude value is 0 degrees. We could instead use 360 degrees, since that's technically... By the way, if anyone joined the video recently, degrees stands for degrees. I'm just...
Не понимаю, почему он использует градусы вместо радиан.
Yeah, that's a good point. I'm using degrees because they're typical for geography, but to make the formula correct, we should convert this 360 degrees into 2 pi, the circumference of a circle. And we should also convert the negative 37. So now we get 0.71 times e to the pi I. As we saw earlier, this is negative 1, so we end up with negative 0.71. Half to the half can give us either of these answers, depending on the tude. And this may seem weird, but it's actually really nice. The 1/2 power is the same as the square root, meaning that the complex numbers naturally have a plus minus with every square root. We can get both answers by changing the tude. For this earlier equation, I made the graph using tudes from negative 180. I forgot what I was going to say. To 180 degrees. But instead, we could use 180 to 5. Oh yeah, well, it's not important. Never mind. 140 degrees. Or we could... Actually, I do want... Enough! We could also graph this equation by randomly picking the angle for each point. These are all valid decisions for how to graph the equation, but we do need to make some decision. And the same idea goes for world to the world. Earlier, we graphed world to the world starting at 0 degrees and increasing that angle around the globe until we got to 360 degrees. The break in the graph is the line where we jump from 360 back down to 0. But we could continue increasing that angle up to 361, 362, 365, 367, 373, 380, 394. But as we're graphing those larger angles, we're covering up the small ones. We can only show one lap at a time. Although we can sort of show multiple laps by randomly choosing the angles, but this is really messy. Instead, we could try making each lap transparent. This does show multiple laps.
Sorry, he thinks it's funny to not finish his sentences.
I did finish that sentence. I just used intonation.
See? There he goes again.
That was also a full sentence. Let's take a further look at this graph. Some parts look chaotic, but others are not. This dark stripe contains the naturals. A natural to itself is always a big natural. And all of the big naturals are around the North Pole, so they're dark blue. The other side has the negative naturals. A negative natural to itself will be near 0, which will be around the South Pole, so they are white. But then the rest of the globe is a mess, since it's the transition between these different states. And because complex exponents are a mess, we also have trouble with their inverse, complex logarithms. E to the pi I equals negative 1. But if we cube both, we get that e to the 3 pi I is also negative 1. And the same goes for the 5th power or any odd power. And this means that if we take the gar of negative 1, it could be any odd pi I. Something similar happens with all other numbers, which means that if we graph gar of the world, we get a break. We can change our angles to move that break, but in order to see the full picture, we need to make a transparent graph. And this one's a lot less messy, because this video is brought to you by They are viewers just like you. For just a few dollars a month, you can get early access to my videos, get your name in the credits, see occasional exclusive videos, and you'll help me be able to make these more often. So if you enjoy... No animals were harmed in the making of this video.